Today we're going to be looking at functions, rules, tables, and graphs. There are three views of a function. You can have the rule, which is the function, table, as well as a graph. So right here, this is our rule. So f of x equals negative 3x plus 1. So we need to make a table. So if these are my x values, this is my f of x. So if we pick some values of x that start with negative 1, 0, 1, 2, and 3. Negative 1, if we plug that into here, negative 3 times negative 1 is a positive 3, plus 1 is 4. Plug in 0, negative 3 times 0 is 0, plus 1, 1. Negative 3 times 1 is negative 3, plus 1 is negative 2. Negative 3 times 2 is negative 6, plus 1, negative 5. Negative 3 times 3 is 9 plus, is negative 9, plus 1 is a negative 8. So now, since we have our rule, we're able to get our table. Now we can graph. These are our x values, y's are the vertical axis. So we're going to graph negative 1, 4, 0, 1, 1, negative 2, 2, negative 5, and 3, negative 8. Alright, let's take a look and see when we need to connect our points and when we need to leave them without a line. Continuous data means when you're looking at measurement, so anything with temperature, weight, length, and that's when you would use a solid line, so when you connect your points. Discrete data is when you're counting items, so the number of people there are, the number of cars outside, and that you would just leave as specific points on your graph. So let's take a look at this example. Suppose your group wants to produce and sell CDs. It costs $250 to produce a master and $3 per CD to produce. We need to create and graph a function to show this relationship. So to create our function or our rule, we need to take a look. We know it costs $3 for every single CD that they make. So we write it as 3x. Plus, they also have to pay $250 just for the master copy. So this is our function. We can figure out and fill out our table. Let's say they don't make any extras. They make 1 extra, 3, 6, or 9. So 3 times 0 is 0. Plus 250, 250. 3 times 1 is 3, plus 250 is 253. 3 times 3 is 9, plus 250 is 259. 3 times 6 is 18, so 268. 3 times 9 is 27, so 277. Now that we have our table, we can then graph. Horizontal is always our x's, y's is always our vertical. So we need to label x's are these numbers, and those represent how many CDs we make. And our y, these numbers always represent how much it will cost. So let's label. Go up by ones. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So going this way, we're going to kind of jog this off. We're going to start at 250 and then go up by 5s. 255, 60, 265, 270, 275, and 280. So 0, 250, 1, 253, 3, 259, 6, 268, 9, 277. Looking at this and knowing what we know, this is going to be a discrete function because we're looking at counting. We want to know how many CDs. So we're looking at 1, 2, 3. We can't count anything in between. So let's look at another example. An automatic photo booth charges $3 for each sheet of photos. So we need to create and graph a function. So our rule, or our function, it's $3 for every sheet we get. So 3 times x. So our x and f of x. So let's say we have 1, 2, 3, 5, and 7. So 1, it's going to cost us 3 times 1, so $3. 2, 3 times 2, $6. 3 times 3, 9. 3 times 5, 15. 3 times 7, 21. So to graph x, y, our x's represent the number of sheets for photos, y, how much it costs us. So let's go up by 1s again for our x values. And let's go up by 2. Let's go up by 2s. Alright, so for 1, it costs us 3, 2, 6, 3, 9, 5, 15, 7, 21. So let's get right up here. Looking at this, we're looking at counting and how many sheets do we have? 1, 2, 3. So this is going to be discrete. So since it's discrete, we do not connect our lines, we leave them as these points. Alright, let's look at our last example problem. A person's weight on the moon is 1/6 the weight that's on the Earth. Create a function that shows this relationship. So the function would be, well, you take 1/6 and multiply it by whatever you weigh on Earth. So if this is our x, this is f of x. Let's look at 50 pounds, 100 pounds, 150, 200, and 250. When we plug this in, we can plug it in our calculator. So 1/6 times 50 is about 8.3. 100, so 100 times 1/6 is 16.7. 150 times 1/6 is 25. 1/6 times 200 is 33.3. And 1/6 times 250 is 41.7. When we look at this type of a graph, this is going to be continuous because we're looking at measurement of weight. We can have half pounds, quarter pounds, so this includes all numbers, so it is going to be continuous, meaning our graph will be connected with a solid line. So when we go to graph this, x is our horizontal, y is our vertical. Our x's represent the weight on Earth, and our y's represent the weight on the moon. So let's label our axes. Let's go up by 50s and skip. So 50, 100, 150, 200, last one's 250. So going up, let's go up by 5s. 5, 10, 15, 20, 45. Alright, so at 50 pounds, we're 8.3, so somewhere in here. 100, we're at 16.7. 150, 25. 200, 33.3. And 250, 41.7. And those we connect with a solid straight line.